Adjacent angles. So that's the first part of our conversation today. Adjacent. That's a word that you know. That's a word that we use in everyday language. So can anybody tell me in your own words what adjacent means? If two things are adjacent, what are they? Let me give you another sentence and let you use some context. Oh, close. So we talk about rooms that are adjacent. So if two rooms are adjacent, what might that mean? I'll give you this hint. My classroom is adjacent to Mr. Dion's classroom. Yes. It is not close. It's I've got it in the chat here. They're next door neighbors. They're right next to each other. So it doesn't mean the same, but it means right next to. So my room, I know some of you have never even been in my room, but my room, my next door neighbor right next to me is Mr. Dion. Across the hall, that's where Mrs. Swanson is. So she is not my next door neighbor. She's across the hallway. Okay. So who's adjacent to me? Mr. Dion on one side, and then Miss Hawk is on the other side, right? I feel the doors are down there. So yeah, it's Miss Hawk, right? It's not that little, yeah, Miss Hawk. So I've got Miss Hawk on one side. I've got Mr. Dion on the other. They're my next door neighbors. Everybody else is either too far away or they're across the hall. All right. So angles actually work the same way. We talk about adjacent angles just like we talk about adjacent rooms or, whatever it is. So I'm going to give you what we're looking for adjacent angles, and then we're going to look at, take a look at some diagrams and establish exactly who is an adjacent angle and who isn't. All right. So let's start with this. Here we go. Adjacent angles must be all of these, or must, let's say, have all of these. So the first thing they must have is a shared side between them. Okay, you can think about this like a wall between classrooms. If you knock on the wall, Mr. Dion's going to hear it on the other side because he is on the other side of that shared wall. Okay, if I knock on the wall, Mr. Dion's going to hear it, but across the hall, Miss Swanson, she'll never hear it because she doesn't share a wall with me. Okay, so I need that, a shared side. So even, let me do an example that's not in school because some of you haven't been there in forever. If you ever go to a hotel room, right, same thing. If you're in a hotel room, if you knock on the wall, the person right next to you is going to hear you through the wall. But if someone's across the hall, they don't hear me. They're not adjacent to me. Okay, so shared side, or you would think about it as a wall. I need to have that shared between us. Okay, the next thing I need for adjacent angles, they have to have a common vertex. Okay, so both angles must share the same vertex. If they don't, they can't be adjacent, right? It's just that easy. It has to be all three of these. So if any one of these is missing, they're not adjacent, okay? And then the last thing is that they cannot overlap each other. All right, so my classroom and Mr. Dion's classroom do not overlap. I have my bubble, he has his bubble. There is no overlap. There's no shared, we share a wall, but other than that, the actual classroom is not shared. They do not overlap. Same thing in a hotel room, right? That would be super weird if one hotel room like overlapped another. That'd be so strange. They're totally separate. So I have a room, then the person next to me has a room. There is no overlap there, okay? So I'm looking for all of these same things when I'm talking about angles. All right, so I'm going to give you a diagram, and then we're going to talk about some angles that are adjacent and then ones that are not. Okay, so let me draw for you this picture. Oh, come on. I'm so over these pens. Do you know that I've sent a message right to Pilot, and I'm like, listen, I have these brand new pens. They're brand new, and they still, like, when I'm drawing a line, it just like fades out on me. They sent me another pack of pens, and I'm like, okay, that's great, cool, but I still have the same problem. So how about we figure out how to fix the problem? I don't know. Whatever. All right, so here is a whole bunch of angles here, and then I'm going to number these angles to make our lives a little bit easier. 1, 2, 3, 4, and I'll call this big one 5. All right, so I'm going to make two lists. I'm going to make a list of angles that are adjacent and ones that are non-adjacent. Adjacent angles. Here we go. And then I'm going to have non-adjacent. Of course, I didn't leave myself enough space, but that's okay. All right, so I'm going to start you off with a pair so you know what to look for. Here's a great pair, angles 1 and 2. They have everything that I said I needed, angles 1 and 2. All right, let's go through the three things. They have a shared side between them. Yeah, right here. If I'm in room 1 and I knock on the wall, room 2 is going to hear me, right? We share this wall. Got it. Do we have a common vertex? Yes, we do. We both have a vertex at point F. Right? For angles 1 and 2, yep, that looks good. And then they cannot overlap each other. These don't. And a really easy way to sort of ask yourself if they overlap or not is if I were to just shade in angle 1, see how nothing that I shade in touches angle 2? Right? I'm not shading in angle 2 at all. I'm just shading in angle 1. We do the same thing. If I were to shade in angle 2, it does not overlap onto angle 1. Okay, so there is no overlap here, so it has all of the three things that I want. They share a side, they share a vertex, and they don't overlap. So I can call angle 1 and angle 2 adjacent. Yes, okay. Can anybody look at this diagram and give me another pair? There's tons of them. Give me one other pair that you see in this diagram that are adjacent. You could send it in the chat. You could call out. I don't care. Oh, 3 and 4. Okay, I got 2 answers. 2 and 3. Perfect. 2 and 3, next door neighbors. Yes. They have that shared side, common vertex, don't overlap. 2 and 3, you bet. I also got in the chat 3 and 4. I agree with 3 and 4 as well. They're next door neighbors. They don't overlap. They have that common vertex. Yes, yes, yes. All right, so let's add 3 and 4 to this list. Okay, so I hope you get the idea of ones that are adjacent angles, okay? Now let me talk to you about ones that are not. Okay, so, or let me ask you this. Does anybody have a pair that they think are not adjacent? Five and 3. Yes, 5 and 3 are not adjacent. So let's kind of walk our way through that. Because how are they not? Well, remember, it has to have all three things that we've been talking about. Number 1, do they have a shared side between them? A shared side, not a shared, I mean, they need a shared vertex, but they need a shared side, right? So listen, if I'm not, let's see, oh, there's Olivia. What time is it? 1:27. Okay. Hello, Olivia. We are talking about adjacent angles, which are basically next door neighbors. And we just said that angles 3 and 5 are not adjacent. And this is why. If you knock on the wall here, you're going to, angle 2, someone in room 2 is going to hear you. That's not 5. If you knock on the wall over here, 4 is going to hear you, not 5. 3 and 5 do not share a single wall between them. They share a vertex, but they also have to share a wall. They don't. So 3 and 5 don't count. They're across the hall neighbors. They're not next door neighbors, and I need next door neighbors. Okay, so 3 and 5 definitely not adjacent. Who's got another pair? Give me another pair of non-adjacent angles that you see in this diagram. 1 and 4, yep, same thing is happening with 1 and 4. Sure, they have a common vertex, but they don't share a single side between them. You knock on this wall, you get to angle 2. You knock on this wall, you get to angle 5. So, no, 1 and 4 don't share a wall. So
2 and 4.
2 and, yeah, yes, 2 and 4 work as well. Let me put them both. 1 and 4, 2 and 4. Let me zoom out a smidge. Both of those for the same reasons, right? There's tons of them, by the way. There's loads and loads and loads of angles in here that are not adjacent. But what I do want to show you is the deal with this overlapping business. So I know you're looking at this and you're thinking, okay, there's 5 angles here, 1, 2, 3, 4, 5. None of them overlap. So what's the deal with this overlapping thing? Okay, yes, we do have angles 1, 2, 3, and 4, and 5, but there's so many more angles in this diagram. So many more. For example, there's angle DFB, which is this whole thing, DFB. You see that? This whole big angle, DFB. That whole slice, that's an angle. Of course it is. So if I wanted to talk about angle DFB and angle 1, let's say, and decide if they are adjacent, well, okay, let's go through the things. DFB and angle 1, they do I guess you could make the argument that they share this side. So, okay, maybe you say, all right, that one's a little weird, but maybe, okay. They do definitely have a common vertex, but they absolutely categorically fail with overlapping. There's the problem. DFC, look at this. If I shaded in angle DFC, I'm going right over angle 1. And I'm not allowed to have any overlap. And I absolutely would there. So those 2 angles, they can't count. So I'm going to add that to my list here. Angle DFC and angle 1. They cannot be adjacent. They fail. Now, that doesn't mean that every time you have a big angle that it fails, because DFC is adjacent to someone. Can anybody tell me? What angle is DFC actually I'm sorry, DFB. Geez Louise. Geez Louise, you guys. Were you thinking, Miss Savia, what's wrong with you? You're writing the wrong letters. It's DFB, not C. Holy Toledo. Glad I caught that. Oh my gosh. DFB, I mean. All right, any Hoosers. DFB is adjacent to someone. Who is it? DFB, this whole angle. What angle would it be adjacent to? I'm actually going to draw right on this diagram. I hope you don't mind. So I'm talking about this angle, DFB, this big old one. Who is adjacent to that one? Who is its next door neighbor? Anybody see? So be careful. I got an answer in the chat of AEF. But AEF, I don't think you mean that one, because AEF would be an angle that I don't even have drawn here. Because remember, the middle letter has to be the vertex. So I'm wondering if you meant... You'd have to have F in the middle. So maybe you mean AFE? Oh, AFE. So the problem with AFE, they would share a vertex, but they wouldn't share one single common side. Right? If you knock on this wall, you're getting to angle 3. If you knock on this wall, you're getting to angle 5. Hint, hint, hint. Those are the ones that would be adjacent to this angle. Right? This whole angle here in blue. That's angle DFB. Who's its next door neighbor? On one side, it's angle 3. On the other side, it's angle 5. So you could have said either one of them with the blue angle DFB. Okay, I hope that makes sense. I'm going to add this to the list. So DFB, and angle 3 would be adjacent angles, DFB and 3. So DFB being the blue angle that I have here, its next door neighbor is 3. You can also say DFB, the blue angle, and angle 5, its other next door neighbor. Okay. Yeah, and you could, if you didn't want to name it with numbers and you wanted to do letters, yeah, DFE works too, because that's just another way to name this angle. So any proper way to name the angle is fine. All right, so I'm going to add DFB, and we also had DFB and angle 5. Okay, we could literally spend the rest of the day making these lists. There's more, way more in this diagram. So I just wanted you to have a snapshot. Hey, here's a bunch that work. Okay, so I'm going to say, and many more. Are we going to talk about the candles too? We have to. So in the last block, I don't know, saying and many more. I always think about birthdays, right? What is it just at the end of happy birthday? Yeah, people just say and many more, right? Anyway, so here's my question to you, because I want to see how widespread this is or not. Do any of you add an extra candle on a birthday cake for good luck? Does anybody do that? Speak out. Tell me. No.
I've never heard of that.
That's so interesting. No, anybody in this block?
Yes, a couple in the classroom do.
Okay, I'm finding this very interesting. And some people, yeah, like some people have never heard of this. They're like, "What are you talking about?" Yeah, it's I don't know. We always did it. We always had one more extra candle on the birthday cake. I've always done it. I will always do it. So weird, right? I didn't know it wasn't a thing until I got to college, and then people were like, "What are you doing?" Like, you don't do this? Funny. Now you think about it, right? Another thing that I have always done, and I thought that everybody did it, when someone gets a new car, you throw a handful of change in the car. Does anybody else do that? No?
No, I've never heard of that one either.
Oh my gosh. Leave it to my mom to like teach me these random things that nobody else does. Nobody else does that? Have you ever heard?
I grew up, my father taught me, if you ever borrow anybody's car, you always bring it back with a full tank of gas.
That is very true.
That's one thing that he taught me, but I've never heard of throwing a handful of change in when you first get it. No.
Yes, it's supposed to be another good luck thing. Like whenever someone gets a new car. I don't know why. Do I do it? Yes. Weird, right? Don't even know where it came from. All right. That's the same thing with like the, I thought it was common knowledge that you put a spoon under your pillow for a snow day and you wear your clothes, your pajamas inside out. I have found out that not everybody does that either, but that's a thing. I'm telling you.
That, believe it or not, I have heard of.
Okay. It's so funny how these things start, right? All right. So Oh yeah, I want to ask you a trick question. Let me turn the page. Okay, trick question. Oh, my camera froze. Come on. It's been going so well for me today. I guess I was due. I'll draw the picture while it's restarting. All right, take a look at this. I want to know, and hold on. Let me get the gallery view up so I can see everybody. So turn your cameras on if they're off. What? Where are you guys? I'm supposed to see you. All right, I want you to give me a thumbs up if you think that angles 7 and 8 in this picture are adjacent. That's the question. Thumbs up if they are adjacent. Thumbs down if they're not. Oh, Steve! How have I never noticed this before? You can push a button that gives thumbs up and thumbs down. Where are you doing that? Oh, and these dots?
You go to reactions at the bottom of the screen, and thumbs up is one of them. You can also do clapping hands.
I know one time I saw like speed up and slow down. Is it here? No, that's breakout rooms.
That stuff.
See, I can't do it. Maybe it's because I'm the host. I can't see it. Maybe is it in the chat?
No, it's just at the bottom of the page, bottom of the screen.
Right next to share screen.
See, I don't have that. I have chat.
Yeah,
do you use this? No.
It's for us. It's reactions right next to share screen. I don't know.
Oh, I must not have it because I'm the host. Let me see if it's over here. How is this day like 200 of remote learning, and I don't know that you could do this? Gosh, what else don't I know? Steve, you have blown my mind here. All right, well, now now I can't even get back to the screen that I was on. Oh gosh. See,
there's no thumbs down though, right?
No, I don't have, and I'm trying to see it on this side, but I can't even. You know me, I push one wrong button and then I'm lost for 10 minutes. So, gosh, wow. I swear I used to be so tech savvy. I was. Well, I was tech savvy when the tech was a flip phone, right? Oh my God. My son plays with my old flip phone now. It's so cute. I love that he actually knows what it is. I mean, he's never actually talked on it because it doesn't work. But anyway, so I forgot what even the question was. Are these adjacent? The answer is no, they are not adjacent. So let's talk about why. I know it feels like they should be, right? Because you're like, well, they've got that shared wall, right? Yeah, I'll give you that, but they fail on the common vertex. See that? Angle 7 has its vertex here, 8 has its vertex here. They don't share it. It's got to be the same vertex, and they don't have it. So we're going to say angle 7 and angle 8, 8 are not adjacent. Because they don't share a vertex. Okay. Oops, sorry. There we go. 7 and 8 do not share a vertex, so they don't help me. All right, so the next portion of what we need to talk about are linear pairs. And luckily, linear pairs sort of tell you right in the name what you're looking for. Whenever you see that word linear, hopefully your brain is immediately picking up on line right there. If you just shorten linear, you get line. Line, line, line. So lines need to be on our brains here. So here's what you need for a linear pair. you are going to need linear pairs must have both of these. They must be adjacent. So if they are not adjacent angles, they can't possibly be a linear pair. All right, so I need to have them be adjacent. And then the second thing that I need is that they need to form a straight line or a straight angle together. Okay, we'll take a look at what that looks like. Form a straight angle or straight line together. All right, so I'm going to show you with my little doodad here what these could basically look like. All right, so here's one part of the doodad. See that? That's just a straight line, right? Great, I got a straight line, perfect. So now what I'm going to do, remember that you can also think about this as a straight angle, right? Aren't all straight lines really the same thing as a straight angle? So what I can do is if I broke that up into two, so if I snap that on there, see how I have two angles now? I have one angle right here, and then I have another angle right here. Together, they make a straight angle. So if I knew that this measured 60 degrees, for example, this would have to measure 120, right? Because a straight angle measures exactly 180. Gets me that half circle. I sometimes think about it like a rainbow. So you have this straight line. I have one angle and another angle. They are absolutely adjacent. They're next door neighbors. And together, they are making this straight line. They add up to be 180 together. All right. Now, this can look a couple different ways, right? I could easily move this pink thingy over here. Those are still a linear pair. They're still doing all the same things that I was just talking about. Right? They're still adjacent. They still make a straight line together. So kind of no matter where this pink thingy moves, that's still a linear pair. You could even move this pink thingy, swing it all the way around. I don't care. Look, you still have a linear pair. It's just down here. Angle 1, angle 2. Together, they're making a straight line. You could turn the whole green line. You could look anything. Really, no matter what I do, all of these are going to be linear pairs, no matter what. As long as that pink thing is attached in the middle there, any angle that you can create like this, any pair of angles, they will all be linear pairs. All of them. Okay, so I'm going to draw some of those out so we have just some visuals in our notes, what they look like. And then I'll show you some that are not linear pairs. Okay, so let's draw out a few that are and that are not. Okay, so let's start with the ones that are. I'm going to divide this up so we don't get confused. Okay, ones that are. So very simply, they're going to have a straight line, and then I'm going to have two angles, 1 and 2. See how together they're making that straight line? Perfectly straight. Okay, linear pairs always do that. It could look something like this. You could have it come straight off. Who cares? Those two angles together still get me a perfectly flat line. They're going to add to be 180 together. It might look like this. Angles 1 and 2 could look like that. Sure, that's still a linear pair. Because look, right here, I have a straight line. I've got that one side that they share in between them. I don't really care where it goes, but then the other two sides are going to make a straight line. All right, so I'm going to draw you one more. I don't know, maybe something like this. And I just want to overemphasize that these two angles are always going to, if that's 120, what's this angle got to be? Can anybody tell me? If that one's 120, this one is?
60.
Yeah, it's got to be 60 because they're making that straight angle together. All right. And I just want to make sure that I state in geometry, remember how I make a big deal? You can't go around assuming that a right angle is a right angle unless it's marked or someone tells you. You finally get to assume something. If something looks like a straight line, it's a straight line. So I don't ever have, that's how he knew that was going to be 60. I didn't have to say anything. I didn't have to add any other additional information. If this appears to be a straight line, you get to assume that, yep, that's a straight line. So that means this whole thing is going to add up to be 180. All right, so that's how we can get to that being 60 without any other additional information being needed. Okay, I hope that's helpful. And so you see these two together. This is where I'm talking about that rainbow or a half circle. Half of a circle is 180, isn't it? So hopefully it kind of makes sense when you kind of look at it that way. Okay, so what's not a linear pair? So we've had lots of things that are linear pairs, but what could a linear pair not be? Well, first of all, anything that's not adjacent. So if you take a look at these two, even though you feel like they might add up to be 180 together, it doesn't matter. They're not adjacent. If it's not adjacent, they don't count. These are not, right? They don't share a common vertex, so it fails right there. Doesn't count. Okay, who else is not a linear pair? Oh, this. These two. These are not a linear pair. They are adjacent. Yes, I will give you that. They are next door neighbors, but they do not form a straight line together. They do not add up to be 180. No. They have the side that's in between them. Okay, that's fine. But then the other sides that make up the angles, look how broken that is. You should be able to draw it with one single straight line, and you can't. It bends. It's broken. So, nope, does not count as a linear pair. Okay, who else is not? Let me sneak back and see what I said in the last one because I thought I had another good. Oh, yeah. Two more examples. I might try and sneak something like this in there. Is that a straight line? One single straight line? No, it's not. Don't let them fool you. That is not a straight line. So if I break this up, no, that does not count because this thing is not a straight line. If it was a straight line, it would go this way. It's not. It's bent. We can't have anything bent and broken here. No. And then the last sort of really tricky kind of one like this. Check this out. If you had that, and we were talking about angles 1 and 2. Now remember, we're talking about a linear pair, not a linear triple. Pair. These two angles. I know you're like, well, there's a straight line right there. So doesn't it count? It does not count because remember, it has to be two things. It has to form a straight line together, which, okay, fine, I see that. But are they adjacent? Are angles 1 and 2 adjacent to each other? I say no. They share a vertex, fine. Where's the wall that they share in between them? Nowhere. You knock on this wall, you get into this room. You knock on this wall, you get outside, I guess. You're not getting into room 1. Doesn't work. Doesn't work. Those two angles are not adjacent. And if they're not adjacent, it doesn't count. Ooh, tricky. Okay. So I know we don't have a ton of time left, but I'm pretty much done. I was going to give you all a more complicated diagram and make you all give me an answer. So I will save that for tomorrow. What I do want to do is I want to quickly grab your homework and just show you a couple of them out. If you feel confident and you're ready to go try them on your own, I'm okay with that. But let me do just a few of them. Let me grab this here. You guys are D block. And let me share the screen now. Yeah, okay, except I don't know where the button is now. Oh, because I got to stop sharing. That's why. Just kidding. Oh, I do have reactions over on this one. That's so the host can't give a reaction? I got a lot of reactions. That's unfortunate. Bummer. All right. Well, now I know that you guys can do it. Oh, I'm so excited. All right, anyway, so you have homework 15 here, you'll see, and you will notice that you have some questions that I made, and there's only one of these ones that's the computer-generated stuff. But there should be pretty straightforward. So when you click on one, let's see here. This particular one asks you to identify if the angles are adjacent and if they form a linear pair. So you're going to need to choose from the drop down for each of these. I say those are not adjacent. Why not? They don't have a common vertex. And guess what? If they're not adjacent, they can't form a linear pair. So I don't even need to look at the diagram again. I already know they do not form a linear pair. They're not adjacent. They can't stand a chance to form a pair. Okay? Because it will mark you wrong and just get these wrong. So I'm saying what you mean to say. I don't even know who sings it. I mean, though, connect stable. Oh no, good thing almost done.
Yeah, you're going in and out.
Can you guys hear me?
Yeah, you're lagging.
You just froze.
I hope she doesn't disconnect.
Just hang on, she'll be back.
All right.
If not, you guys know what your homework is, but give her another minute or two.
Okay.
There is a homework 15, all right, that she'll make live, and that's on adjacent angles and linear pairs. So that's what she was doing, was just going through a couple of examples. Up, Mrs. Sable, Mrs. Back.
Hi, I'm so sorry. I don't know what happened, and then my hotspot didn't connect fast enough. Or anyway, so yeah, I was just showing you guys a few, but we're out of time anyway. Does anybody have any questions before we go, or anything I can do for anybody? Anybody need anything? We're all right? Okay, guys. Well, sorry about that. Did I lose everybody? Oh no, you're all pretty much
No.
still here.
I told them, hang on.
Well, thank you. All right, guys. Any questions? Anybody? Anything? Nothing?
No, but it's homework 15, right?
Yes. That sounds right. Homework 15. All right, and there is my alarm. So, okay, guys, I will see you all tomorrow. Have a good night.
All right.
Ms.
you-
Lebierte, thank you so much for your help.
Bye, guys.
Thank you. Bye, everybody.
Bye.